Hello everyone, and welcome to Programming Fundamentals, Chapter 2 video lesson. I am Professor James, and I will be your tour guide for the duration of this course. Let's go ahead and get started. As you notice, I have provided you guys with a video lesson worksheet that will give you an interactive experience as we go through the plethora of concepts, rules, syntax, and definitions. So I hope you guys will follow along with me as we go through each of these exercises. Well, let's go ahead and look at some of these terms. Things like semicolon, IOStream, main, the pound sign, braces, literals, those kinds of things. I want to start off with the very beginning. When you are creating a C++ program, each of your executable statements must end with a semicolon. And this is done so that the C++ compiler knows when the statement is done. Otherwise, without it, it'll continue to interpret everything you've typed as if it is one single statement. And what's nice about the compiler, if it continues to do that and it notices something is wrong, it'll let you know that it is expecting a semicolon. And if you want to be reminded what a semicolon looks like, there's a symbol right here. All right. Oh, it's telling me something is spelled incorrectly. Okay. Now, when you also work with things like display, getting input, formatting your text, things like that, we actually have to tell the C++ compiler which library to use in order to call those commands in our statements. And we do that by using what we call a pound include, and that is from the preprocessor directive. Now, the one that we use to display text, calculations, numbers is IOStream. And I'm going to show you a block of code a little later so you can see how all of that works. Now, when working with C++, every console program that we create must have what we call a main function. You guys have seen in your reading, it's called int main. And if you don't have that, the compiler will not execute your program. Now, back to the IOStream. If we wanted to include this in our program, the library IOStream, we would have to place the IOStream value in what we call a preprocessor directive. That's this little puppy that you see here. Now, every preprocessor directive begins with a pound sign. Now, we're not just stuck with including libraries. We also have one for defining identifiers, but that's a little more high level that we will explore later in the course. Now, when we're working with the main function, and as we get into more complicated concepts like if-then, while loops, do-while loops, all of those things will have to be enclosed in what we call curly braces. So that's a very important player here in C++. And the curly braces are essentially these, which is the shift square brackets. Now, when you see numbers, single characters enclosed in single quotes or apostrophes, or words or phrases enclosed in double quotes, these are what we call literals. These are those values that they don't change. 72 is 72, uppercase A is uppercase A, hello world is hello world. And we use these in our output, we use them in assignment statements, those kinds of things. We use them to perform comparisons, and they're referred to as literals. Now, when we're talking about numbers, we have a few different types of number representations. If you're looking at positive and negative whole numbers, including 0, we have integers. If you have decimal numbers, then we have real numbers. And if you have, really large numbers or very small numbers, you can write them in scientific notation. which is pretty much something like this. So 978.65 times 10 to the 12, oops, I changed that to 14, can be written in E notation in this particular format. So it's pretty much scientific notation without the times 10. Now, when we are working with different types of data, we have to think about how much memory storage will that data need to take up. So something like a simple character only requires a byte of memory. And when we're talking about things like a string, like the letter A in double quotes, it requires 2 bytes. So a single character is stored differently than a string, which is literally a string of characters or a group of characters. And you will find in chapter 2, when you're looking at the different data types, that not only do they have different memory sizes or capabilities, they also have different ranges. They have a max and min that they're able to support. Now, assignment statements is pretty much the heart and soul of programming. This is where you take your data, you assign it to a variable, and then the value is stored essentially in a memory location in RAM. And we have a very simple rule when using assignment statements. The left side must be the name of the variable. The right side of the equal sign will be your literal. It can be a literal like a number, a character, a string, or it can also be another variable, or it can even be an expression, a calculation. So when we're looking at these three, we're asking, is there a variable on the left side? And so we look at these. Total is a variable. Your age is a variable, but 72 is not. 72 is not a variable. It is a literal. It's a number. So we cannot have a number on the left side of the equal sign of an assignment statement. We can only have a variable on the left-hand side. Now let's take a look at working with character variables. Character variables, their job is to store a single character. It can be A through Z, uppercase, lowercase. It can be digits 0 through 9. It can be special characters that you find on your keyboard. Now, what's very important is when we assign them to a character variable, the single character must be enclosed in single quotes. So let's go ahead and take a look at these. Which of these are valid statements? Well, if we look at letter equals W, letter is a variable. That's what the compiler is going to see. And on the right side, we have the letter W. Well, the compiler is going to assume that W is a variable also. So this is valid because we can always, on the right side, have a number, a character, a string, or variable, or an expression. And of course, whatever we assign to the left side must match the data type of the left side. So here we have a character variable called letter. So we're assuming that W is also a character variable. And so that would be valid if W was a character variable. Now if we look at the next one, but here, because we don't know what W is, we cannot make that assumption. So therefore it's not a valid one unless we knew that W was declared. Now if we look at the next, letter equals W in single quotes, that is very valid because there's no doubt what W is here. W is a single character, and we're storing it in a character variable called letter. Now in C example, the right side has a string. We know it's a string because W is enclosed in double quotes. Because it's enclosed in double quotes, it is a string. We cannot store a string in a character variable. We can only store a single character, and it must be enclosed in single quotes. Now let's take a look at our cout statements. there are some rules here. You start off with the keyword cout, and then that's followed by the insertion operator. Now this pretty much tells the compiler where you're going to send this literal. So the string hello is going to be sent to, it's going into the left, into the console output, which is our monitor. So this is how we're able to see hello on the screen. The indel tells us that we're going to press enter afterwards. Now this next one, the cout and the insertion operator, that looks really good. The hello string literal, that looks really good. And so does this insertion operator. Now, because we have a string and then we have a new line, we have to separate them with an insertion operator. However, we have an issue here. Here's the new line character. It cannot stand alone. It has to be enclosed in double quotes in order for us to display it. So we will get an error here because it's missing the double quotes around it. And now this one is a fuzzy area, just like A up here, where we're like, well, if W is a variable and it is a character variable, then we can assign it to letter. Well, here it's valid if hello is a variable that has a value, whether it's a number, a string, or a single character stored in it. So that's why I put a question mark there, because it just depends on if hello is declared as a variable. If it's not declared as a variable, then nothing is going to be displayed and we'll get an error message because it's looking for either a valid variable, a string literal, numeric literal, or a special character. If it doesn't see any of those things, then it's not going to run the program. Now here we're looking again to see which ones are not valid. Well, the cout statement, that block there is good. Hello world is enclosed in double quotes and it's ended in a semicolon. This is good. Now if we look at the next one, hello world is all by itself out there. It's going to think it's two variables. However, if we want to display two variables, we cannot display them this way. We would have to place the insertion operator in between them. So this is not valid. It should be either enclosed in double quotes, or hello and world should be two separate variables separated by the angle. So because it is not following the rules of a string literal or actual variables, it is not valid. Now that brings us down to this one down here. Here when you have string literals, you can place them together in one literal in double quotes, or you can separate them like we've done here. And you're probably saying, why would we separate them if they're two words? Well, it's a lead-in for some things that you guys will be doing in the future, to where you will be separating some of your string literals and you'll be placing actual variables in between them. Now here's where it gets fun. I love this. We're assuming that X is 4, Y is 7, and Z is 2. We want to know what's the value that's going to be stored in the variable result by each of these statements. This is where we get a chance to do some arithmetic. So just like in algebra, we are going to replace or substitute or plug in 4 for X, 7 for Y, 4 plus 7 is 11. For B, we're going to replace Y with 7, and 7 times 2 is 14. And for C, we're going to replace Y with 7 and Z with 2. Now, if we do 7 divided by 2, we have the propensity to the result would be 3.5, which is true in the real world. But in programming, the compiler divides integers, those whole numbers, differently. What it does is it divides them, but it only gives us the whole number portion. Because technically this is 3.5. The whole number portion is 3. And so it will only return 3. It will not return the 0.5 because your dividend or the numerator is a whole number and your divisor or denominator is a whole number. So because they're both whole numbers, we get the whole number answer only, not the 0.5. And there are a lot of uses for that in programming and problem solving. Now we have the same expressions, and let's go ahead and work these out. But there is something weird here, and I look forward to you guys telling me what it is. Oh, right. So first we're going to add 2.5. Oops, I have typos here. Okay, it says what value will be stored in integer result. So it's an integer variable result. Now we have 2.5 plus 7.0, which is 9.5. However, result is an integer variable. So that means it's only going to store the integer portion. An integer variable is never allowed to store a decimal. It only takes in the integer portion of the answer. So that's why result will equal 9 versus 9.5. Then we have 7.0 times 2. That's run of the mill. It's going to be 14. You're probably saying, why isn't it 14.0? By default, if the decimal is 0.0, it's not going to display it. Now, the fun one, the previous one I said if you divide integers, you're going to get an integer answer. Here we're dividing a real number by an integer. So it should be 2.33, right? It's not because result is an integer. So it's only going to store the integer portion of the answer. So even though it's 2.33, 2 is the only thing that's going to be stored in result because result is an integer. All right. So I hope you got it, and never hesitate to go back and review any of the things that we're covering here today. Now, the next one, we're going to be writing statements that declares variables in C++. So when we talk about real numbers, the data type is called a double. Excuse me. When we are working with whole numbers, the data type is int, which is short for integers. And we're working with strings, it's string. When we're working with characters, it's char. So here we are declaring 3 variables. They all have the same data type, which is double. So it says write a statement that is going to declare all 3 in the same statement. So we can actually start off with the data type, which is double, variable 1, comma, variable 2, comma, variable 3. We can declare 20 of them in one line if we wanted to. Not a good idea, but you can. And you make sure that they are separated by commas, and the compiler will know to reserve space in memory for each of them. Now for number 16, we are declaring 3 integer variables in the same statement, but we're also doing what we call initializing 2 of them. To initialize, you will basically, immediately after stating the name of the variable, you will place it equal to the initial value. So months equals 2. Comma, days, we're not initializing days, so it's just all by itself. It doesn't have a date. Comma, years equals 3, because we're giving it initial value of 3. And notice that they're all in with semicolons. Now I really love 17 because this is how we talk. We talk like this. Add 2 to D1 and store the result in D2. That is something that we would say as human beings. But to tell the compiler to do that job, adding D to 1, that is done on the right side. And then storing the result in D2, you place D2 on the left, because that's your memory location that you want to store this result in. Multiply D2 times 4 and store the result in D1. Once again, D2 times 4. We're going to store this result in the D1. So remember, whatever you want to store, it needs to be on the left-hand side. And all of your calculations, numbers, and literals will be on the right. And the compiler will actually evaluate an assignment statement from the right. It'll do what's happening on the right first. That result will then be stored in the variable that's on the left. Store the character letter K in C. You place the variable C on the left side. Remember, K must be enclosed in single quotes. Now, when we're talking about ASCII and integers, this is where it gets fun. I'm going to confuse you a little bit too. There are four. There's 4 integral data types in C++. Int is the foundational, that's short for integer. Then we have long, which is a much bigger integer number, and it takes up more space in terms of memory. We also have bool, which is Boolean, true or false. True as being 1 and false being 0. And then we have character, char. All of those are integral. Now, of course, with the char, the integral value, actually we can easily convert into a single character and vice versa. So let's go ahead here. So if we wanted to store the ASCII value for the letter uppercase K, and in the integer variable I, this is all we have to do. Now this is what the compiler will do. The compiler will take K and convert it into its ASCII value. And you guys have an ASCII table. I believe it is in chapter 3 for you guys to explore. But it will automatically convert it for you, which is really neat. Now this should be I. Also, gotta love Microsoft Office for auto-correcting everything. Now we're subtracting 1 from I and store the result back in I. Well, we take 1 from I. That's what we see here on the right side. When we're done evaluating this, its result's going to be stored in I on the left side. And that is the interpretation. Now, here we're going to get a little more complicated, but then not so much complicated. So we're subtracting, now we're working with double numbers. We're working with the NI and then double D1 and D2. So here we're going to subtract 8.5 from D2. Remember, that's done on the right side. And then that result is then stored in variable D1. So the variable you want to store in is always on the left of the equal sign. Divide D1 by 3.14 and store the result in D2. So on the right side, we're going to divide D1 divided by 3.14. And then we're setting it equal to D2 when we're done. And this is just like a little extra practice. So to set the ASCII code for the letter F in C, so C equals the letter F enclosed in single quotes. D, we're adding 1 to I and storing the new value back in I. And that's another, it's a very important statement. The I equals I plus 1 and the I equals I minus 1. These are very powerful assignment statements that you will use a great deal throughout this course. Last but not least, add D1 to the current value of D2 and store the result back in D2 as its new value. So, right side, we're adding D1 to D2. So here we go here. And whatever that result is, we're going to store it back into D2. It's pretty much like having a cup. You have a cup with 2 ounces of beans in it. And then you have a teaspoon of salt. Okay? And say, for example, you want to add that salt to your beans. Well, you just pour it in there, and now you have 2 ounces of beans and a tablespoon of salt. But it's still the cup of beans. It just has added things to it. Or you can do the opposite, where you want to take the 2 ounces of salt out and then just be left with the 2 ounces of beans. So we can look at the variables not as memory locations. You can look at them as cups of something, a cup of beans. And I think that will, shed a lot of light on what variables are. All right. Outputting text is pretty interesting. We want to write this so that we are printing 2 blank lines between each of these. Now, here's one thing I have to say about all compilers. They're not very smart. They only do what we tell it, and we have to tell it in a way that it can understand, because it has a limited vocabulary and very strict grammar. And we call the grammar syntax in programming. So here we place like 2 lines, but we're not going to see that if we actually ran it. We would actually see that entire passage all in 1 line, because we didn't tell it to enter a new line. So here is what I would do to have 2 blank lines in between. So this first /n, notice that these are escape sequences inside of the double quotes. So this one is just going to press enter. So whatever we type next will go right underneath 2 mandolins. So this is where this /n comes in. We press enter a second time. So now there is 1 line break. And then we do the third one here will give us 2 line breaks. And we do that for each of these so that we can get that effect. Now you're probably saying, is there another way we can do it? Absolutely. I'm going to get rid of one of these, and I'm going to just add an indel here. This works the same way as these 3 inside of string literals. Now, heaven forbid, you really don't want to work with /n, which is the new line. You can go ahead and do this if you like. But it really just depends on your preference and what's required or expected. All right. We're not going to do the read the code in this video, because it's going to make the video really long. I'm going to give you a taste of what we're going to do next in the next video. Really exciting. Read the code. Okay. So here we're rewriting the statement, the cout L, E, A, Eve, where we are going to, instead of using indel to press enter, we're going to use the new line escape sequence instead, which is the \n. So instead, because it can be placed inside of the string, we just embed it this way. So we have the letter L \n. So that gets rid of this indel. This indel goes bye-bye because we have placed this new line character. We do the same thing for E, A, and F. So this indel and the insertion operator is now replaced with \n. There are times when I want to see that end of line, so I will go ahead and do the angle indel. And other times, if you want to be nice and clean, then do the new line character inside of your string literals. Alright, this concludes this particular video, but I'm going to come back and show you a video about reading code. Go ahead and give you a taste of it. We have a few I was going to walk you through. Fixing code, that's called debugging, and typing a program and fixing it. So we're going to actually do the fix the code 2 ways. We're going to look at the code line for line, character for character, and then we're going to type it to see what it does. Well, that's it for now, guys. Let's go ahead and take a break. and I will see you in a few in part 2.